Imagine walking onto a manufacturing floor. It's just buzzing with activity, right?
Yeah.
You've got precision robots, skilled people working alongside them, that sort of low hum of machinery.
Yeah, highly tuned stuff.
Exactly. Now picture this. A brand new car rolls off the assembly line roughly every 57 seconds.
Wow, that's fast.
It's an incredible pace. But here's the really wild part. Unlike, the old factories churning out thousands of identical things.
Some Model T days.
Right. Almost none of these cars are the same. Every single one is built to individual customer specs for markets all over the world.
So you got different models.
Different models, different engines,
Uh.
internal combustion, plug-in hybrids, full EVs.
All coming down the same line, not separate lines.
The exact same line, one after the other. It's
Yeah.
kind of mind-bending.
That really is the defining challenge of modern car making, isn't it? Mass customization, but at, like, breakneck speed. It completely flips the script on traditional standardization. How on earth do you maintain absolute premium quality, making sure every single unique car is perfect, when you've got that much variation and that kind of speed?
It seems almost impossible. Contradictory, like you
It
said.
really does. It's a massive challenge.
Exactly. And, when we think about artificial intelligence in cars, usually our minds jump to self-driving features, maybe.
Navigation or predicting when it needs service, maybe?
Yeah, stuff that happens after the car's on the road.
Right.
But what if AI wasn't just in the car, but a key tool used to actually build it? Specifically to tackle this huge quality control headache right there on the factory floor.
Ah, now that's interesting.
That's the really fascinating idea that came up in an article we found in Quality Digest. It looks at a very specific practical use of AI in manufacturing. It focuses on a pilot project at BMW Group Plant Regensburg.
Okay, BMW. That makes sense. They're known for complexity and premium standards. So this takes AI out of the future lab and puts it right into a tough, real-world factory setting.
Right. They're using it to guarantee the quality of these super complex cars that are being made incredibly fast. How do you check that unique mix of features, that specific engine type, built under real factory conditions?
Meets the exact same tough standard as the completely different car that came before it.
Exactly.
Yeah.
How do you verify that consistently?
So that's our mission for this deep dive. We're going to take this source, this Quality Digest article about BMW Regensburg's Gen AI 4Q pilot, and really break it down.
Get into the nuts and bolts.
Yeah, we want to understand how BMW is using AI in this really targeted way. What specific problem is it solving? What are the benefits they're actually seeing? And maybe most importantly, what does this tell us about where quality control is headed in these complex, high-speed factories?
So it's like a shortcut for you, the listener, to get up to speed on this really cool intersection of manufacturing and AI.
Exactly. Think of it like that. It's about seeing how AI can, boost human expertise, help people master this complexity and scale. AI not just automating things away, but enabling a level of precision that maybe wasn't possible before.
Okay, so let's start by really digging into that core challenge. You mentioned mass customization and speed. The article gives us the scale at BMW Group Plant Regensburg. They make about 1,400 vehicles every single day.
1,400 a day. Just try to visualize that. That's like a small town's worth of new cars rolling out daily.
It's huge. And the pace, as the article says, is just relentless. A new car off the line every 57 seconds.
Less than a minute.
Less than a minute per car. Yeah. You have to keep incredibly high quality standards in a process that's just constantly rapidly moving. There's no buffer time to meticulously check every little detail manually on every car in the same old way.
You just can't. Not at that speed.
Right. So speed is one half of it. The other half, and maybe the tougher one for quality, is the sheer complexity and variation. The source really hammers this home. It emphasizes that each vehicle is built to individual customer specifications.
For the global market, too.
For the whole world.
Yeah.
This is where modern manufacturing is so different, isn't it? It's not one size fits all anymore.
Absolutely not. And think about what individual customer specifications really means for a car. It's the specific trim, the upholstery they picked, the driver assistance package, the infotainment setup.
Regional requirements, maybe?
Yeah.
Different parts needed for different countries?
Yeah, exactly. Different regulations, right down to maybe special paint colors or wheel options. Any combination seems possible.
And then on top of all that, you have the manufacturing flexibility they've built in. The article points out they're making different drivetrains, combustion engines, plug-in hybrids, full EVs.
All on the same line. You mentioned that before. That's still kind of staggering.
The same single production line, not
Yeah.
separate ones. plus, like you said, countless model and equipment variations.
So the car being worked on right now might be totally different from the one that just finished 57 seconds ago.
And completely different again from the one just starting down the line. It leads to this phrase in the article that just perfectly captures the challenge. Virtually no two vehicles are alike.
That's it right there.
That one sentence is the absolute core of the quality problem they're facing. If every single thing you make is essentially unique, how do you apply a consistent, reliable quality check at speed?
Yeah, and that's where the old ways of doing quality control, standardized checklists, visual checks, looking for flaws against one single template, they just become incredibly hard, maybe impossible to use effectively at this scale and speed.
Right.
If your checklist has, say, 50 points, but 30 of them don't even apply to the specific car in front of you because it's a different variant.
Your inspector is wasting precious seconds.
Exactly. Or worse, they might miss the 5 really critical checks that are unique to that car's specific configuration because they're buried in a generic list.
Or think about how components interact. Maybe, I don't know, a specific combination of an electric drivetrain and a certain option package needs a unique calibration check. Or maybe it creates a potential stress point that only exists on that exact build.
A human inspector, even a highly trained one, would struggle, wouldn't they? To keep track of the thousands, maybe millions of potential unique quality points across every possible car configuration.
And remember exactly what to check on this specific car in that tiny 57-second window.
Precisely. You need a system, something to dynamically tailor the inspection for each individual car as it comes off the line, to guide the human expert to exactly where their attention is most needed right now.
Which perfectly sets the stage for why they looked at AI. The problem is crystal clear. High speed plus massive variation makes the old one-size-fits-all quality checks just impractical if you want to guarantee premium quality on every single unique vehicle.
Yeah, the old methods just can't keep up with that level of dynamic complexity.
Okay, so that's the huge challenge. And the article introduces the solution they're piloting to tackle it, the GenAI 4Q pilot project at BMW Group Plant Regensburg.
GenAI 4Q. They don't explicitly say what it stands for, but generative AI for quality seems like a pretty good guess, right? Suggests it generates insights or guidance.
That makes sense. And it's described as a software solution developed at BMW Group Plant Regensburg.
That's a key detail, I think. It's not just off-the-shelf software they bought. It implies it was built specifically there, probably working closely with the engineers and quality folks on the ground.
Tailored to their exact needs, their specific production line.
Right. And the core idea, it's actually pretty elegant, even if the tech behind it is complex. The AI acts as a learning-based analysis tool, a quality booster, its main job, to deliver tailored inspection recommendations for each specific customer vehicle.
So not a static checklist anymore. It's a dynamic, personalized inspection plan for every single car rolling off the line.
Exactly. There's a quote from Rudiger Romick. He is responsible for test floor and finish there. He says straight up, our AI tool generates an individual inspection catalog for each specific customer vehicle. That's the key output, a custom roadmap for the inspector.
Okay, so the AI makes a custom checklist. But how does it actually do that? For a car built in under a minute, with all those variations, this is where the article talks about the data. It says the AI analyzes vast amounts of data.
Which is always the fuel for AI, isn't it? Its power comes from finding patterns in data way beyond what a human could process.
And the article specifies what kind of data. First, there's vehicle data, such as model and equipment variant.
Okay, so that's the basic info. What the car is supposed to be based on the customer's order, its DNA, if you like.
So if a car has, I don't know, a specific sunroof option, the AI knows that and could flag the sunroof seal as something to check.
Precisely. It knows the car's configuration, but here's where it gets really interesting, and this is a crucial point to dive into. The AI also analyzes real-time production data for each specific vehicle.
Real-time production data. Okay, let's unpack that. Why is data about how the car was built important for a quality check after it's already assembled?
Great question. Because it's not just about the final product specs. It's about the journey that specific car took through the factory. Think about all the sensors, the automated tools on a modern line.
Robots, torque wrenches, vision systems.
Exactly. They all generate data constantly. Temperatures of welding tips, the exact torque applied by fastening tools, pressures in hydraulic systems, data from cameras checking things earlier in the process, cycle times at different stations. even maybe the temperature in that part of the factory when a specific step happened.
So the AI could be looking at tiny variations in these manufacturing parameters for each individual car as it goes through.
Yes, that's the key. It connects the what the car's configuration with the how, the specific conditions and process data for this particular car's build.
Can you give an example of how that might work?
Sure. Let's say the AI has learned from historical data that when a specific type of rubber seal, one used only on certain variants, is installed by Robot B, and the sensor data shows the ambient humidity in that zone was slightly higher than usual during that specific operation. Maybe there's a tiny, almost negligible, but statistically higher chance of a minor cosmetic issue with that seal later on.
Okay, wow. That's a connection a human inspector could never make, right?
Yeah.
They just see the finished car. They don't know the humidity reading from station 12 3 hours ago.
Exactly. Or maybe a particular automated screwdriver, while still operating perfectly within its allowed tolerance range, recorded a torque value at the upper end of that range on a set of bolts for this specific car. The AI might know from analyzing thousands of past vehicles that on this model variant, that slightly higher torque sometimes correlates with a potential minor alignment issue found later in the final check.
So it's picking up these super complex, subtle patterns hidden in this massive stream of real-time data.
Right. Patterns and correlations that are completely invisible to the naked eye or to standard process monitoring. It's learning these connections from the factory's own collective experience, but on a massive scale.
That's like a continuous learning loop then.
Absolutely. The AI takes the static configuration data, what the car is, the dynamic process data, how it was built, mixes it with historical quality data, what issues have been found on similar cars built under similar conditions, and uses all that to predict the most likely areas needing a check for this specific vehicle right now.
Okay, so the AI crunches all this data, finds these incredibly subtle patterns.
Yeah.
What's the actual output for the inspector? The article says it quickly and automatically determines the scope of the inspection and organizes it intelligently in the right order.
And that's the practical magic delivered to the human on the floor. The scope is tailored. Instead of a generic list of, say, 100 things, they might get a focused list of 15 highly relevant things to check on this car.
Because the AI has flagged those 15 based on the data for that specific VIN.
Exactly. And organizing it intelligently in the right order is also key. It means the steps might be grouped logically, maybe by location on the car, or by the type of check to minimize wasted movement and time, which is critical when you've only got 57 seconds before the next unique car shows up.
It's really about making the human inspector's skilled work more focused, more efficient, giving them a precise, data-driven roadmap for each unique car.
Precisely. It's AI augmenting human expertise, directing their valuable time and attention to where the data suggests it will have the biggest impact for that specific vehicle.
So this customized plan is generated by the AI. How does the human inspector actually get it and use it on the factory floor? The article mentions a smartphone app.
Yeah, that seems to be the interface. It connects the AI's brain, so to speak, to the human action. The AI sends the individual inspection plan within a smartphone app used by the trained specialist doing the final checks.
Makes sense. Everyone knows how to use a smartphone. It's portable. So presumably they walk up to the car, maybe scan the VIN,
Or QR code, yeah.
and bam, the app instantly shows the tailored checklist for that specific car.
That seems to be the workflow, yeah. The app delivers that individual inspection catalog already organized intelligently in the right order. And usability has to be key, right? Especially under that time pressure. The article highlights intuitive usability makes it easy to record findings.
Yeah, you can't have inspectors fumbling with complicated menus when they need to quickly note something down.
They need to be able to rapidly document any issues, a tiny scratch here, a slight misalignment there, maybe a function check that didn't quite feel right.
So how do they record those findings? Just typing.
Well, probably different ways. Maybe a simple check boxes for standard pass-fail things, text input for descriptions. But there's another really interesting feature mentioned. A microphone icon in the app activates voice recording.
Voice recording. Okay, why is that useful?
Think about it. You're in a factory. Maybe you need both hands to feel a panel gap or look closely underneath something. Speaking your findings is often much, much faster and easier than stopping to type on a small screen.
Right, you can just describe what you see or feel.
Exactly. It allows for richer, more detailed input than just ticking a box. An inspector could say, slight scuff about 2 inches long on the driver's side rear door handle, way faster than typing all that.
Okay, that makes sense for efficiency. And the AI isn't just giving the plan, it's also involved in processing the feedback, right? The article says the AI also manages speech recognition and transcription using standardized coding.
Now, this is a really critical part for continuous improvement. Let's dig into that. The AI listens to the voice note, uses speech recognition to turn it into text, okay, standard stuff, but then it goes a crucial step further. It uses standardized coding.
Standardized coding, what does that mean exactly?
It means converting that potentially free-form description, like slight scuff on door handle, into structured data. Think of it like assigning consistent, predefined tags or codes.
So instead of just text, the system might translate that phrase into something like defect code scuff minor, location code door rear drive, component code handle, something structured like that.
Exactly, that's the idea. Assigning a consistent code for the type of defect, its location, severity, maybe the component involved. This standardized coding is absolutely vital
Why vital?
because it transforms the descriptive human feedback into data the AI can understand and learn from. Unstructured text is hard for machines to analyze systematically. Structured codes are easy.
I get it. So the AI isn't just using historical data to create the inspection plan.
Right.
It's also capturing the results of those inspections, including the detailed voice notes from the inspectors, now structured via this coding, to continuously update its own understanding, to improve its pattern recognition for the next car.
Precisely. It closes the loop. The AI suggests checks based on what it thinks is important from the data. The human performs the check and reports back in a structured way, and the AI learns from those findings.
So it learns if its predictions were right.
Yeah. Did it flag a potential issue that wasn't actually there? Or, maybe more importantly, was an issue found in an area the AI didn't flag? This feedback constantly refines the AI model over time. It makes the system dynamically smarter with every inspection performed.
That's a really powerful system. It's not just deploying AI once. It's creating a living, learning quality process that gets better and better based on real results from the factory floor.
It's the AI learning from the sheer volume of unique production data and unique inspection data it's processing every single day. That's the power of machine learning in this context.
Okay, so what are the big picture benefits? Why is BMW doing this? The article mentions some direct outcomes, makes quality control more efficient, faster, and more reliable.
And in an environment like that, extreme complexity, high volume, breakneck speed, getting efficiency, speed, and reliability all at once, that's kind of a holy grail, isn't it?
Yeah, usually you have to trade one off against the others.
Right. Efficiency comes from focusing the inspection only on the high probability areas for that specific car. Speed comes from the tailored, organized checklist and easy input like voice recording. Reliability comes from the AI's ability to consistently spot those complex, data-driven correlations that predict potential issues, things that are just beyond human capacity to track across so much variation.
And this isn't just a standalone project, is it? It fits into BMW's bigger picture. Armin Ebner, the head of the Regensburg plant, is quoted saying, "The use of artificial intelligence supports the digital transformation of BMW Group production toward an intelligently connected factory."
That quote really underlines it. This AI quality system is a key piece of a much broader strategy. It's part of what BMW calls the BMW iFactory framework.
iFactory, what's that about?
The article explains it's focused on digitalization, aiming to create a digital and intelligently connected factory. Basically, a factory where everything is interconnected and generating data.
So a future where data streams from every part of production are linked, and smart systems like this AI are analyzing that connected data to optimize everything, not just quality.
That seems to be the vision, yes. This AI for quality is a concrete example of how that digitalization translates directly into better operations and better products. The source explicitly links this to optimizing our production processes and creating added value for our products and ultimately for our customers.
Okay, let's connect those dots. How does faster, more reliable quality checking specifically optimize the whole production process and create value for the person buying the car?
Well, think it through. If you catch potential problems more reliably and earlier,
You avoid costly rework later.
exactly. Less rework means smoother production flow, less wasted time and materials, potentially higher overall throughput. That helps the factory's bottom line and efficiency.
Makes sense.
And for the customer, the value is pretty direct. Getting a car with fewer defects right from the start. That reinforces the whole BMW premium quality image, reduces hassles like warranty claims or trips back to the dealer.
leading to happier customers.
Right. Higher customer satisfaction.
Yeah.
It's a clear line from this AI tool analyzing data on the factory floor to a better experience for the end user. It's using tech to deliver on that brand promise, even when manufacturing is incredibly complex.
It's also really important to stress something the article makes clear. This system isn't about replacing the human inspectors.
Absolute critical point.
It supports the trained specialists who still examine each finished vehicle once more to confirm it meets premium quality standards.
Yes. The AI is an augmentation tool, not a replacement. It doesn't make the final call on whether a car is good enough. That's still the job of the skilled human inspector.
So the AI provides the smart guidance.
Exactly. It points the inspector to the most likely areas of concern based on all that complex data crunching. But the human brings their years of experience, their eyes, their sense of touch, their expert judgment to actually do the physical inspection and make the final quality decision.
It's a powerful team then. The AI handles the massive data analysis, the pattern finding, the custom roadmap. The human applies their unique senses, dexterity, and complex judgment to execute the check and sign off on quality.
It lets the human inspectors use their high-level skills more effectively, focusing on where they're truly needed for each unique car, instead of spending time on routine checks that the data suggests are very low risk for that particular build. It's about making skilled work more effective, not getting rid of it.
Okay, let's zoom out a bit and put this project in context. The article gives some background on the BMW Group Plant Regensburg itself.
Yeah, it's a major facility, been operating since 1986. It's one of over 30 BMW production sites globally. So this isn't some small experimental shop, it's a big, established, high-volume plant.
And clearly a top performer. The article notes it was named Factory of the Year in 2024 for excellent large series assembly in a major European competition.
That's a significant award.
It really is. And it suggests the plant was already running at a very high level before this AI pilot even started. So the AI isn't being brought in to fix a broken process.
That's a great point. It's more like a tool to push an already excellent operation to the next level, to help master that extreme complexity that even the best traditional methods might struggle with.
This BMW iFactory idea they're implementing sounds pretty transformative too, creating a digital and intelligently connected factory, even to the point where you can experience in virtual form what the factory will look like a few years from now.
Yeah, that points to a really deep integration of digital tools, data, and simulation into how they design and run the factory itself.
It's like building a factory where data isn't just a byproduct, but something actively used by smart systems to make better decisions everywhere, optimize flows, and enhance what people can do. This AI quality tool is just one visible piece of that bigger digital vision coming to life. And focusing on this kind of advanced manufacturing tech at Regensburg seems clearly linked to BMW's future cars, right? The article mentions the upcoming production ramp-up for the new E-Class vehicles there.
That's a crucial connection. The new E-Class is BMW's next big thing, a new generation of vehicles, new architecture, heavily focused on electric, digital, and sustainability.
So probably even more complex to build. New materials maybe, more complex electronics, advanced batteries.
Very likely. The manufacturing and quality challenges for those cars could be even greater than today's.
So this AI quality system is being developed and proven now to get ready for that, to build the capabilities needed to ensure premium quality on those even more advanced future cars.
That makes perfect sense. It's future-proofing their quality processes, developing the tech now in preparation for the increased complexity and, frankly, higher stakes of building their core products for the next decade. It's a strategic investment in future quality.
The article also briefly mentions the nearby Wackersdorf plant. What's the significance there?
It gives a sense of the regional ecosystem BMW has built. Wackersdorf makes cockpits, supplies parts for overseas plants, and importantly has a new battery testing center that opened just last fall, in autumn 2024.
Battery testing. Okay, that seems directly relevant to building EVs and hybrids at Regensburg.
Absolutely. Ensuring battery quality and safety is paramount for electric cars. Having a dedicated, state-of-the-art testing center nearby directly supports the quality goals at the Regensburg assembly plant. Wackersdorf, also making cockpits and supplying parts, shows the complex network and logistics that Regensburg relies on. Quality upstream matters, too.
And just to put a human scale on all this tech, the source mentions the core staff at both locations is around 9,250 people, including about 350 apprentices.
Yeah, it's a reminder that even in these hyper-advanced, digitized factories, there's still a massive human element, Skilled workers, engineers, technicians, trainees, they're all essential, and their capabilities are being amplified by systems like this AI.
One last detail. This system wasn't built entirely in-house. The article notes the AI quality inspection was developed in collaboration with a Munich startup, Datagon AI.
That's interesting and pretty common, actually. Even huge companies like BMW often partner with specialized tech firms, especially agile startups focusing on niche areas like AI. It helps them accelerate development and bring cutting-edge solutions onto the factory floor faster.
Okay, so let's try and wrap this all up. We've seen the massive manufacturing challenge at BMW Regensburg, building something like 1,400 basically unique cars every day
Mixing combustion, hybrid, electric, countless options.
at that blistering pace of one car every 57 seconds. And this huge variation makes traditional standardized quality checks incredibly difficult, maybe even obsolete for guaranteeing premium quality.
Right. And we've explored how their Geni i4Q pilot tackles this using AI. It analyzes just tons of data, both the car's configuration and real-time data about how it's actually built.
To spot complex patterns and generate a tailored, intelligent inspection plan specifically for each individual car.
hmm And that personalized plan gets delivered through a user-friendly smartphone app to the trained human inspectors. The app even includes features like voice recording.
Which the AI then processes using standardized coding, turning those spoken notes into structured data, creating that crucial feedback loop for continuous learning and improvement.
Exactly. And the result is quality control that's much more efficient, faster, and more reliable. This directly feeds into BMW's bigger strategic vision, the iFactory concept of a digital, connected factory. It optimizes production, reduces waste,
And ultimately delivers real value to customers by ensuring that premium quality promise holds up, even on these incredibly complex, customized vehicles.
and all this innovation is happening at an award-winning plant, Regensburg, partly as preparation for building the even more advanced Neue Class C cars in the future. It operates within a supportive regional ecosystem, including vital facilities like the Wackersdorf Battery Center, and relies on a large, skilled human workforce whose expertise is being augmented, not replaced.
It really is a powerful real-world look at how AI is moving out of the lab and onto the factory floor today to solve some of the toughest problems in modern manufacturing, basically, mastering complexity and variation at an incredible scale.
It's a practical application with tangible benefits.
So why should this deep dive matter to you listening right now? Well, this isn't just some niche story about how one company builds cars. It's a really vivid example of how AI is being used not just to automate tasks, but to fundamentally augment human skills in situations that are just drowning in complexity, data, and speed.
Yeah, it shows AI acting as a precision tool, enabling a level of personalized guidance and quality assurance at scale that just wasn't possible before.
It also demonstrates that in these complex industries where human skill is still vital, AI is increasingly being used to make that skilled work more effective, more focused, and better equipped to deliver high quality in incredibly dynamic conditions. It's not just about replacement.
It's about enhancement, amplification of human capability.
Which brings us to a final provocative thought for you to chew on, based purely on what we've learned from this source material. Given that the article explicitly states virtually no two vehicles are alike, and they're produced every 57 seconds, is this kind of AI-driven, tailored inspection simply the only realistic way left to truly uphold premium quality standards in this hyper-fast, hyper-variable manufacturing world?
Or maybe. Does it mean the very definition of premium quality control is actually changing, shifting away from standardized universal checks towards hyper-personalized, data-driven inspections tailored for each unique item?
And what is this specific blend AI providing the guidance, but the human expert making the final critical judgment tell us about the future of skilled work in manufacturing? A future where our human senses, our judgment, our dexterity are increasingly amplified by these intelligent learning systems. Something to think about, as the products we use every day are increasingly built in factories just like this one.